Hello and welcome to Shenzen IO. This is a puzzle game where you basically program microcontrollers to meet the objective of different levels in the game. It came out actually in 2016, published by a company called Zachtronics. They made a whole bunch of puzzle games that had pretty good following. I don't think they're any longer in business, but we're going to jump into it. From reading the reviews on this, it does get quite complicated, so we're going to see how far we can make it. I've not watched any videos on it. I'm going to try to challenge my brain and see how far I can make it. Occasionally we might have to use a lifeline and look something up, but I'm going to try for the most part not to do that. Now this game actually has a instruction manual that comes with it. It is like 47 pages long. Up here, this is the manual right here. It has 47 different pages. There's a little bit of fluff in here, but there's still like at least two-thirds of it is good information. But basically explains some of the concepts of the game and what we're looking at there. There's some commands we can look at here. It's actually pretty simple on the command front, programming language wise. There's not a whole lot you can do. These 2 pages here list basically the commands you can use: move, jump, sleep, add, subtract, multiply, and then these are some test ones that you can do: test greater than, test less than. So we'll definitely refer to this from time to time, but that way you know where it's coming from. I'm going to try to actually post these videos as I record them. Sometimes I record a whole bunch and then post it over time. This one I'm going to try not to do that with. I'm going to try to post it as soon as I do it, so that way you guys can leave me some comments and hopefully I can learn what and how to do it better. So let's jump right into it and see how it goes. Okay, we got a welcome email. We basically work at this company called Shenzen Electronics. We have to design products for them. This is another email that says basically read the manual, so it's very important, I guess, that you understand what you're doing. My guess is there's not much of a tutorial. It looks like this is our first project, the security camera. But this basically says that it has 2 different lights on the security camera. One blinks randomly, one blinks at a regular pattern. I'm guessing we're going to have to program that. So let's just jump right into it and see. We got some information tab down here that says active and network are simple outputs connected to LEDs. So these 2 buttons here are connected to LEDs. We basically have to turn them on and off. And this is control the active network outputs with fixed repeating signals as indicated in the verification tab. We'll take a quick look at that, but this is connected up to the P tab. There's like X tabs and X pins and P pins. P pins basically can output a value of 0 to 100, and X pins can just output negative 999 to 999. So, and basically X pins have to be sent to another X pin from what I can tell, because they need to be reading and writing at the same time. So we'll get into that, but click on this verification tab here. We have active simple output, so this is what the active output has to look like. So basically 0 is off and 100 is on. This needs to be off for, looks like, I don't know, 6 seconds, and on 1, 2, 3, 4, 5, 6. Yeah, so 6 seconds off, 6 seconds on. So basically they did this one for us. This one moves 0 to P0. So it sends a signal of 0 through here and turns the LED off. It sleeps for 6 seconds, and then it moves 100 to P0, which is right here, and then turns it back on to 100. It sleeps for 6, so this will just repeat the signal here. We got to do something down here in the network one. We have this pin over here, this tab here. We're going to put that down here. We're going to draw this over to there, and then we're going to try to program this. So basically we want to move 0 to P0, and then we want to let's see, how long is that? We're going to sleep for 1, 2, 3, looks like 4. So we're going to sleep for 4, and we're going to move 100 to P0. That will turn this light on, and we want that to be on for 2 seconds. So sleep for 2, move 0 to P0, sleep for, looks like it's only turned off for 1, move, I don't know how many commands we're allowed to do here, move 100 to P0, and sleep for 1. So that'll basically move 100 to P0. It'll sleep for 2, so it'll go to here, then it'll move 0 to P0, which will turn this off. It'll sleep for 1, it'll turn it back on, sleep for a second, and then it'll go back to this, which will be move 0 to P0, and it'll go for 4 seconds. So we can kind of step through this and you can see what it's doing. So as I hit step here, it's basically working through our program with us. You can see it's on this step right here. Nice, so that should go up now. So yeah, we're following the thing here, so it's looking good. So the bright orange line is following that line, so that's working for us. So let's just go ahead, hit play. I guess we'll simulate it. So it's going to run it a couple times to make sure it's working. But yeah, so super simple on that one. We just had to turn it on and off. And basically pause. Now these are the results. Each level has like a scoreboard that other people have completed in. It looks like we did the same as everybody else. I'm not going to worry about this too much. Move on to the next one. So this one basically has a control in as a simple input connected to a factory equipment. Okay, so this is an input here. Control out is a simple output connected to the other factory equipment. The signal from control in should be multiplied by 2 and copied to control out. So that seems pretty straightforward. This is what we want to do here. This is what in's going to look like. And this is what out's going to look like. So we only have this thing here, so let's drag this in here. Now this is like the MC4000. We can look at the manual real quick. So right here, this is the data sheet for the MC4000. But basically, it's allowed 9 lines of program. It has one general purpose register, which is this ACC. We can use that to store a number in it. It has 2 X-bus pins and 2 simple pins. So the simple pins are the 0 to 100. The X-bus pins are the synchronized ones that are negative 999 to 999. So that's good enough for now. I think send this in here. And send it out here, right? Okay, so I think what we're going to do here is we're going to initially move P0 to ACC. I'll take whatever values coming in at P0 and move it to the ACC, which is basically a stored register. From that point, we will multiply by 2. So I believe that just multiplies the ACC by 2. Like any of these commands automatically apply to the ACC. And then we will move ACC to P1. So it should basically take the signal in from P0, put it in ACC, multiply it by 2, and then move it out. And then we want to sleep for 1, so it waits for the next cycle. Looks like it's working. Like, to give you an example, like let's hit this one and hit sleep for 2. And you can see how it's going to look like if it's wrong. So you can see right here the signal slept for 2. So it's all over the place now. So you can see it's doing it wrong. We've got a whole bunch of red marks. So let's put this back to 1. Looks like we're doing good. It's going to run a couple different tests on it to make sure you have it correctly. Nice. Looks like we did good. We stayed in the average of what everybody else was in. Okay, the next email is about basically completing the game of solitaire. I think we're going to skip that for now. We're going to hit this pulse generator. Let's open this in the concept here. Let's grab a new design, and this one wants this. So this button is a simple input connected to a button. So this is connected to a button somewhere. Pulse is a simple output connected to an electronic device. And when the button is pushed, generate pulses as indicated in the verification tab until the button is released. So let's check this out. We have to do basically this. So this means this button's going to be on for this amount of time. Looks like 1, 2, 3, 4, 5, 6, 7, 8 seconds. And then while it's doing that, we want this pulse button here to be generating this signal. Okay, so there's no really discernible pattern in this button, in the input button. So we're going to have to do a test, I think. Let's grab this in here. Let's grab this to the P0 here. Let's grab P1 to the output. And we have up to 9 lines. So what we can do is I think we're going to do test if equal. So that'd be TEQ, test if equal. And we're checking P0 to see if it's 100. So we're testing P0 to see if it's 100. If it's 100, we put a plus sign down, and this will basically be what it does if it's true. So if it's true, we want to, there's a command called not, I think we're going to try that. Not basically takes ACC, and if it's 0, it makes it 100. If it's anything else, it makes it 0. So basically it'll check ACC and reverse it in this case. So that's good there. If it's not 0, like if P0 is not 100, we want to make sure we move 0 to ACC, and then let's send move ACC to P1, and then sleep for 1. So let's see if this works. That basically will take P0, if P0 is 100, which means this is on, it'll start the pulsing. So which is not, it'll basically make it alternate. Yeah, so that way if this is 100 and if we turn it off here, it moves 0 to ACC and that turns it off. And we'll see what it does. Looks like we are good. They did it in power usage of like, I don't know, less than 240, but I don't know, like, and they used less lines of code here, so I'm not too worried about it. Let's just make sure we complete the puzzles and move on. Next up is light up signs. Let's check that one out. So in this one we have to click 0 and click 1 are simple outputs connected to display segments corresponding to a clicking animation. Drink 0 and drink 1 and drink 2 are simple outputs connected to display segments corresponding to a drinking animation. Okay, so control the display segments with fixed repeating signals that's indicated in the verification tab. So 0 and 1 are outputs, so are drink 0 and 1. So I don't know, let's see what that means. Okay, so it looks like 0 and 1 are outputting this signal here, so 0 is outputting basically the opposite signal, it looks like. And then we have drink 1, drink 2, and drink 3 here. It looks like there's a little pattern here, so when drink 0 is always on. When it's off, it starts this signal here. I think we're going to need a whole bunch of these things here. Let's grab this one, just stick it over here. We're going to grab P1 down to there. We'll grab P0 down to here. And this will be the clicking ones. Click 0, click 1. So let's just do, see, so click 0 is going to be P0. So move P0 to 100. Oh, I did that backwards. Move 100 to P0. Move 0 to P1. And we're typing move, it has to be 3 letters. And sleep for 1. And then just do opposite, basically move 0 to P0. Move 100 to P1 and sleep for 1. So I should handle the control one, I think. It looks like the top 2 here are doing what they're supposed to do. So drink 0 needs to be off for 1, 2, 3, 4, 6 and sleep for 4. So let's start with that one. Sleep for 6. We're going to move 1. Actually, we need to come up here and move 100 to, I guess we'll just say P0 for now. That'll basically move it. For drink 0 here, we're going to move 0 to P0. That'll move 100 to P0, that'll turn it on. We're sleep for 6. And then we will move 0 to P0. It says it's not connected, we'll get there, but and then we got to see how much, like, I don't know if we can squeeze all this in, so we would have to do move 100 to P1, sleep for 1. We're handling this one right here now, the middle one, drink 1. So we're going to sleep for, we're going to move 0 to P1, sleep for 2, move 100 to P0, and move 0 to P1. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code, which we don't have enough because we need to sleep 1 after this. Just for instance, we're going to just see if this works the way I think it is. Yeah, so it's kind of working. What if we just do a different board for each? Can we fit 3 boards in here? So I'm wondering if this is just the best solution here. This would be here, this would be here. And we could probably move this one down to here. Keep it simple. So drink 0 is move 100 to P0. That's going to be off for 6 seconds, or on for 6 seconds. Move 0 to P0. That's going to be off for 4. And that should be it for that one. Yeah, looks like that's working. Something similar over here. We're going to move. So we're actually going to change this around a little bit. So we're going to sleep for 6, move 100 to P0. And this time we're just going to sleep for 1, move 0 to P0, sleep for 2, move 100, to P0, sleep for 1, and we gotta turn it back off, right? 0 to P0. Let's see if that works for drink 1. Looks like that's working just fine. And this one is a little bit different. Like it has a repeating 1, 2, 3, 4, 5, 6, 7, 8 seconds here, but this first one, 1, 2, 3, 4, 5, 6, is only 7 seconds. So let's try something similar. I think we can just copy this. Control V, so we're going to sleep for 7. Going to move 100 to P0. We're going to sleep for, it looks like it's on for 2 seconds. Move 0 to P1 and sleep for, I think we can just sleep for 1 second, right? And that should work. Delete all this. So this will basically fix the offset, right? Because this sleeps for 8, but in the first one it only sleeps for 7. So 7 and 1, it should work. Let's just try it. Looks like we're working. Nice. And you can kind of see this is like the lights lighting up as these things animate. Let's simulate it. Nice. Looks like it's working. We probably have like way too much power usage compared to whatever people have done. A lot of production cost here. We had 12, which is way above the average, but it works. These are pretty good here. So So that's a first look at Shenzen IO. We will actually take a look at some other levels coming up in the next episode. Thanks for watching. We'll see you next time.